Welcome to C# Essentials. This course is a series of videos intended to help beginner developers and beginner developers in the C# programming language to get started and build their confidence. In this episode, we're going to focus on basic variables, local variables as we call them, and the data types that they can be associated with and the values that can be assigned to them. We're not going to look at all data types, we're only going to look at a few of them, but from your basic knowledge you should start growing a bit of confidence in your ability to learn about the other more advanced data types as we continue through this course. So we're going to look at typical variable declarations, as they're known, when we declare to C# that we have a new variable that we're going to use for something in our program, in our app, and how we assign initial values to those variables. And then we're going to look at the VAR keyword, var, which is relatively new to C#. It was introduced quite recently in the 25-year-odd history of the C# programming language, and it has some special characteristics and is intended for convenience use. I personally don't use it at all, but it is there and it does work, and I'll show you how it works and what it's useful for. In the third episode of this series, we looked at simple data types of string and float and int, and we're going to look at int more in this episode, but instead of float we're going to use double instead. Technically, for all of the examples that we're going to use, we could have used float. Technically, float, being smaller, more compact and more efficient, is more appropriate for small real numbers than double is. However, every single example you'll see out there in the wild will use double instead of float. So we've elected to do the same to simplify your learning experience. So we won't use float anymore in this series. We'll use double instead. And then we have decimal. Decimal is a numeric value as well. Now, important thing is that integers cannot have fractions. Doubles and decimals can have fractions. But a double is what is known as a real approximation. It approximates the value of a real number, maybe an irrational number, something where you divide something by something and you can never get an equal result. Pi is an irrational number, for example. The fractions in pi carry on infinitely as far as we know. And the point is, when you are using pi, you don't actually care what the smaller parts of the decimal values are. The fractional part is. You don't care. You just want it to always be exactly the same because it represents pi. In contrast, decimals also have fractions. They're also numeric values, but we care about the exact value of the fractional part. Very common example is money. When you're representing a financial value, a money value, where you care not only about the pounds or dollars, but also the pennies or cents portion, and the fractional part must be exact. It cannot be an approximation because it's going to be used in other critical arithmetic operations, for example, where the results need to be precise. In this episode, we're also going to carry on looking at our frequently used non-numeric data types. String we looked at in the third series, the third episode. And we're going to continue using string on and off throughout the rest of this course. Bool, so remember, string can contain any sequence of alphabetic numeric characters, punctuation marks, special characters. It's a general purpose variable. It's probably the most common type of variable that you would use in a C# program, but it doesn't have a significant, measurable, operable numeric value, so you cannot perform arithmetic operations on a string. If you had a numeric value that was represented in a string, you'd need to convert it to a numeric value first before you could perform arithmetic operations on it. We're also going to look at Boolean, and Boolean is something that can only represent a logical true or false value. We'll see how these are used in the course of this episode. There's also date time, which is very frequently used, but we're going to use it in the next episode after we've discovered some other aspects of the C# programming language. Before we continue, please remember that the best way to learn how to program is to get your hands dirty, to try hands-on examples. And this is why most of the episodes in this series are largely recordings of hands-on demonstrations in VS Code with narrative and supported by occasional more theoretical slide content. If you have missed previous episodes and you'd like to catch up, there is a link in the comments to the playlist for this series, but it's also shown to you on the screen right now. So you can go there and go back to previous episodes of this series. Please like and subscribe. This really helps us to continue to produce this content and to help others and others who need to learn more about C# and programming in general. Please also share. Anybody you know that could benefit from this content, please let them know that it exists. And also, very importantly, please comment. Please let us know if you think we could do better, if you would like to suggest that we can improve certain aspects of our content. Please let us know. We really treasure your input. Thank you. For our first example in this session, we're going to replace our default console app with a simple message that says, please enter your input, and a space afterwards. We did a similar exercise to this in part 3 with the basic C# application. We're going to follow up on that theme. What we're going to do here is we're going to ask the user to provide an input, and then we're going to take the input from the keyboard as we did before and assign it to a string variable. So I'll call the string my string to keep it simple, equals to console.readline, and that was it. And we've seen before that what will happen here is that the console will display the please enter your input prompt, and then we'll be able to type something in and assign it. And this is the important thing. We have a string variable. The variable is a local variable. We will get back to what local variable means in the context of our app, and also what the alternative would be, a global variable versus a local variable. We'll look at that later. Don't worry about that right now. Right now, what we're doing is we've got a local variable. We've called it my str for my string, just to keep it short. Notice that we, in Visual Studio Code and VS Code, we can hover over it and it'll show us that it's a string, my string, it's a local variable. And it's also showing us the squiggles, the yellow squiggles under the console read line, and it's saying, warning, that this could result in nothing. It could be that somebody just hits enter or something, and we'll get back to that later. Don't worry about that one. And we also saw earlier that we could have a console.writeLine, and we could interpolate string values. So we could say we're going to show in here that my string value was my string. Let's do that. In other words, what I'm going to do is display on the terminal mystr colon and then a space, oops, and then instead of that typo, we're just going to type my string. We've seen this before. Just for the sake of completeness, I'm briefly going to show you what happens again. So I've started a new terminal. Remember, I can go to the menu, select terminal, new terminal, or control shift grave accent or back single quote, doesn't matter, and I can type in .NET run. As we mentioned before in exercise 3, we can ignore this warning for the moment. It's kind of a nuisance warning, to be honest. Ignore it completely. What we're starting with is over here. This is where our prompt is. Please enter your input, and I'm going to type in ABC and hit enter. And then, okay, and then I get the output, and there's my interpolated string output. So there's a string, it contains the literal characters, the constant literals, mystr colon, and a space, and then substituted in there is whatever value I typed in at the keyboard. That's great. We can do similar things, so let's have some other variables here. To make things a little bit more interesting, I'm going to go back up here, and I'm going to say that I'm going to have a double. Now, we used float before. We used the data type float. We're going to, from now on in this course, we're going to use double. The truth is that float is more correct for what we're doing right now, but most examples that you will see online or wherever, they will use double rather than float. A double is just a very large capacity float variable, and most people prefer to use it, so we're going to stick with that convention to avoid confusion. But they are largely the same for real number values below certain limits. But I'm going to say double, my double, and I'm going to assign it a value. So I'm going to say that this value is 3.14159, which is obviously pi truncated to a small number of decimal points, decimal places. So here's my double. It's called my double. It's warning us right now that it's never used. That's a nuisance warning again. Don't worry about it. You can turn these warnings off if they annoy you, but I'd strongly suggest you leave them where they are, because you're going to become more sophisticated in your C# quite quickly, and then sometimes these warnings could help you spot silly errors, silly oversights in your code. Anyway, so we have a double, my double, as a variable, and it's assigned a value. And then what I'm going to do is I'm going to say int, my int equals to 123, let's say. And what I'm going to do is I'm going to go down here, and I'll type in my double, whoops, my double, and put its interpolated value in there, and then we'll do my int. Now, the important thing here is if we just run this up again, it's kind of reasonably predictable to understand. If I type in my input for my string, you'll see there's my double. It's got a fraction. That is the significance. It's a real number. It's a floating point real number. It has a fraction, or can. It is allowed. It has the capacity to have a fraction, whereas an integer doesn't. Let's try this. Let's say that I wanted to assign 3.14159 to this value, to this variable. You'll see I get an error. C# is what we call a strongly typed programming language. That means that when you assign or perform operations with numeric values or data variables, you need to use the right data types. So this value over here is a floating point. It's a real number. It's a fractional numeric value, whereas this is not. This so an int cannot take a fraction. So we can, for example, say my int is equal to 2, and that's perfectly acceptable. But we can't assign 3.14159 to an integer because it's not compatible. They are incompatible data types. And we can see I don't need to run this again. If I run it, it's kind of predictable what the outcome that we're going to get. So we can work from the red squiggles, the error notifications that we're going to get for a while. Now it turns out that what if I said, well, I want my integer value to be double or 3 times whatever my double value is. I could, for example, say what I want to do is I want to say my int is equal to, if I said 3 times my int, that would say take whatever the current value of my int is, which is 2, and multiply it by 3 and assign that back to 3. And that's all very well and good, and we'd get 6. I'm not going to, you can try that on your own and you'll see that you get 6. What I want to show you is what happens when we try this with an incompatible data type. So my int is obviously compatible with itself. It's an integer. What happens if we do my double? Let's try this. And it says, oh, hang on a minute, that's a problem. It's saying, and if you hover over this with your mouse, you'll see the error message. You cannot implicitly convert a double to an int. There is an explicit conversion. Did you mean to use that? Are you missing a cast? What is a cast? Well, we'll see what a cast is a bit later on in the session, but it's very often known as a typecast. But what we can do here is we can just say, I know that that is not compatible. So I have prefixed the name of the incompatible variable, my double. I've said to it, I intentionally want to take the value out of this variable, my double, and convert it to the int equivalent. Let's try this. Let's see what that does. If I take this 3 multiplied out, let's see what happens if I just do this on its own. Type in something. Okay, let's have a look at this. This is the important stuff. 3.14159 is the assigned value of my double, and my int was 2, but then we assigned the cast, the converted, or it's actually technically known as a promoted numeric value from the double, and we took the integer part of that double value, which is just without the fraction, so it's the 3. It doesn't have the fractional part, and we took whatever that part is and we assigned it to my int. If you're familiar with mathematics, you'll know about the floor operation, and it's roughly the equivalent. We've rounded it down to the next lowest integer value. Okay, so what we've learned here is a couple of things. We have variable types, double, int, and string, for example. There's string. We can assign them values. We can assign them constant values, like here we've got constant values, 3 and 2. And we can assign them values from other things. And we can also apply operations to them, arithmetic operations. Multiply, we can use plus, we can use minus, we can use multiply, and we can use divide. Okay, so the string is assigned a value, but it's assigned a value from something else that's happening. We call this a function or a helper method. We'll come to these later. Don't worry about them right now. Just know that there are a lot of these, what are known as helper methods, or possibly you could call them functions. As we'll learn technically in C#, there is no such thing as a function because everything is a method of a class, but don't worry about that. Same thing, it's all semantics. Right now, we've got this thing somewhere out there that knows how to read a line from a keyboard input, and it's associated with console, and it assigns that value to the string. So that is our first really simple example of having some variables, assigning values to those variables, and taking input and displaying input. Another perspective that you need to have insight into in C# data types, for numeric data types, is the difference between decimal and double and obviously integer. So integer, we know what integer does. Excuse me. Note that all of them can be assigned a numeric value, and that's great. And the only reason these squiggles are here is because we're not using these variables for anything right now. But obviously we know that we can't assign to an integer, we can't assign a fractional value because an integer doesn't have a fractional value. So fair enough. What is the difference between decimal and double? Well, double and its smaller sister, float, are approximate real number values. They have extremely high precision values, but they are inexact. Decimal is an exact fractional value. What you need to know right now, at this stage in your journey into C# is really two things. If you are doing something scientific or engineering, you are probably talking about a double or a float, depending on how large the value is. Let's just assume, to keep it simple, it's a double. But if you are working with financial values, so money, etc., where the fractional decimal points are significant, where you do not want to lose the significance of very long decimal numbers. Maybe you've got a fraction that is, I don't know, 20 decimal places long, you will use decimal. So the only thing you need to know about them right now is that decimal is an exact, precise numeric value that can have a fraction with a lot of decimal points, whereas double and float are approximate real numbers for very large real numbers, things like irrational numbers, for example, like pi and things like that, where we don't care what the least significant digits of the fraction are. If you are assigning a value to a double and it has a fraction, then you will do this. For example, we saw this earlier. But if I try to do the same thing here, I get an error. And the reason is because C# needs a way to differentiate between whether or not you meant a decimal value or a floating point or double value, which is the 3.14 done. And so what you need to do, if you're assigning a constant value to a decimal, you need to put an M just after that. It's just something you need to know. It's just a convention. It helps C# to differentiate between constant static values that are for type decimal versus for type double. Okay. For many years of C#'s development and evolution, all local variables had to have a data type and a unique variable name for their scope, for the place where they were declared. And over time, the C# development community decided that they should introduce the var keyword, VAR, to allow us to declare variables in our C# apps for which we need to give a unique name, but we don't need to specify the data type, because the data type can be inferred from the value that is provided or assigned to the variable. A couple of things before I show you what this looks like. This can only work with local variables. We haven't got to global variables and other scopes of variables yet, but suffice it to say, you can only do this within the curly braces of a function that we are looking at right now, similar to what we're looking at right now. And you need to assign a value or initialize your variable with an appropriate value of it with a correct syntax in order for the data type to be inferred, and we'll see that in the examples. Okay, so we saw in previous examples how we can have specific, explicitly declared local variables with a given data type like double string and int. How does it look if we decide to use var instead? Well, let's do that. I'm going to say var, my double var, equals to 3.14159. And then I'm going to type in var, my string var, equals to hello, and I'm going to type in var, my int var, equals to 1234. So as you can see, what I've done here is I've basically taken these variable names and I've suffixed them with the word, the var string there, and then I've prefixed them with the keyword var instead of giving them a data type. However, if I mouse over my variables at the top, you'll see that you can see that in the the second line from the bottom of what pops up, it says double my double, and then if I mouse down, string my string, and int my int, and that's because we obviously declared these variables with these names, and that's all very well and good. However, what's interesting to note is that if I mouse over these variables, it's the same behavior. I get double my double var, and then if I go down a bit, it says that's a string, string, my string, a var, and then my int var. You'll notice that there's a subtlety, by the way, is that what it showed us for the string down here was basically it said this is a string question mark my string var. I'm just going to give it another name. What that means is the question mark says that this variable is allowed to have a null value. For many years in C#, not only did var not exist as a keyword, it was kind of introduced because of languages like Python that use inferred variable types as a convenience factor. But also, originally in C#, we assumed that every variable that could be nullable was permissible. It was sensible to do. But then the problem is sometimes people started working with values that didn't have value, variables that didn't have values that were null, and then that causes exceptions. And we saw some examples of that earlier, but we'll see them later in the course again, where we have null value exceptions. So what the C# community did was they introduced the concept of suffixing a data type with a question mark to indicate that the variable is specifically allowed to have a null value. Otherwise, if we don't declare it with a value, then it'll be complained about. We'll get warnings. However, that's not the point of our demonstration right now. The point is that we have explicit data types for declarations, and then we have inferred data types for declarations, and it works very good. They're interchangeable. I would exercise some caution. I come from the old world of writing programs for a living, where it says that you should be as explicit as possible. So if you mean something, type it into your code. To me, this is kind of lazy. I mean, why not just type in double or string or int? Why use var instead? It makes no sense to me. You're not gaining any value from it. It's a shortcut. It's just a convenience factor, and it can have some downsides. So if, for example, you accidentally intended to do something like this, for example, to have a string, you can see this is still a string, but it contains numeric digits only. Let's, to avoid confusion, let's use 5, 6, 7, 8. That's all very well and good, and you can see that this variable, if I mouse over it, is still a string variable. But if I accidentally forgot to put the quotes around it, then suddenly it's an integer value instead, which can lead to problems later. For example, if this was a string, then I could do something like, let's say console.writeLine, and I can interpolate in here the length of my string is, and then I can, in these parentheses here, I can say my string value, my string var, and I can put dot, and if I go down in this list here, you'll see that one of them says length. It's a little bit further down. There it is. It's a property. It's not a method. Okay. And if I run this now, .NET run, takes a little while. What happened there? Oh, I'm in the wrong folder. My apologies. Okay, so I've corrected that and everything's saved and I'm in the right folder now. So if I run my simple little app, you will see that it says the length of my string is 4, which is exactly what That is a nuisance. Don't know why they allow that stuff to pop up unsolicited. It really annoys me. Anyway, so this is great, and life is good. But had I accidentally not put the quotes around here, suddenly this is an error. This dot length is an error, because the dot length after a string variable name says show me the length of that string. For example, 4 characters. Now, if my code was many, many lines long and I couldn't see it all on one screen, I may not be aware that this error had suddenly occurred. I'll figure it out later, but it'll take me a while to figure it out maybe, because I thought that this was a string, but actually it's an integer, and an integer doesn't have a length. So when I try to run it, instead of getting my result, I'm going to get an error. It says the build failed. There's a problem, and what it's saying is this length property here doesn't exist for an integer. Now, there's a couple of problems with this. This is one of them, is that sometimes you can make mistakes if you're not explicit in your code. If you don't take the trouble to explicitly declare your variables, it is quite easy later on to inadvertently assign the wrong values or operations to those variables and then get unpredictable results. The other thing is, if you are just viewing your code from a normal text viewer like Notepad or something like that in Windows, you can't mouse over variables and see what their variable types, their data types are. There's no capability. That only exists within an IDE like Visual Studio Code or whatever. So I would urge a little bit of caution when you are using these features, to think it through and ask yourself, do you really need the convenience and the laziness, or could you possibly just take a little bit more trouble to type in the data types that you intended, so that it's always visible from any application that you're viewing the code from, and also prevents you from making unfortunately silly assignment errors. Anyway, that's var. It does work. It's a convenience, and it's been in C# for quite a few years now, into 2026. I think it's been around for about 5 years as a feature of the C# programming language. Thank you for spending your valuable time with us. Please join us for future sessions and learning how to code and to code in C#. Please remember, as much as possible, to try to experiment with the hands-on examples we are showing you in these episodes. Please like and subscribe so that other folk can get the benefit from this content. And also, please let us know if you have any recommendations about changes we can make or topics we can cover in the future. Thank you.